Okay, let's continue the discussion now talking about the next two products. And remember, the first one, the carboxylic acid, was the result of a double oxidation of an alcohol or a single oxidation of a aldehyde. And the other is an ester, which is the result of a reaction between an acid and an alcohol. And we'll talk about this just a little bit more. A carboxylic acid contains the carbonyl group with the second oxygen bonded to the same carbon by a single bond with a hydrogen. So as we discussed in near the end of the last section, this represents a double oxygenation or an oxidation of an alcohol. So your alcohol is oxidized the first time to form an aldehyde, and then the second oxidation occurs when a second oxygen is bonded to the same carbon that first oxygen was bonded to, and this forms the carboxylic acid. An ester, on the other hand, contains a carbonyl group with a second oxygen bonded to the same carbon by a single bond, but instead of being at the end, again, it's in the middle, and it forms what looks like a salt. So we'll show this in a little bit more detail in the next few slides. And these are just some examples of carboxylic acid and esters. For example, this is an ester. It has the double bond here, a single bond O here with a carbon chain continuing out here. Same thing here, double bond O, single O here, double bond O, single O. And you'll notice if you look at these, raspberry, apple, etc., these all have a very interesting aroma, and that's one of the characteristics of esters, is they tend to have various fruity smells and are responsible for some of the various fruity smells that we encounter. So esters, as I said, are responsible for the odors associated with various plants and their fruits. So on the left here you have the double oxidation of ethanol. Ethanol is oxidized the first time to ethanal, and then the second time to ethanoic acid. Now another name for ethanoic acid is acetic acid. Now over here we have the reaction between this ethanoic acid and another alcohol, methanol, to form this ester, and I'll show you how that happens in the next slide or two. So the functional group of the acid is shown on the left here, and this is the functional group here, and then the R would be right here, and I put a circle around it so you can see that this is what designates a acid and it's always on the end of the chain. This is always on the end of the chain. Now you notice this functional group looks very similar to this, but instead of being on the end of the chain, it's in the middle of the chain, okay? And so that's how you can tell the difference between an ester and an acid, is you have the same setup, functional group, but in one situation it's on the end, in the other situation it's in the middle of the chain, and the first situation results from two oxidations of an alcohol or a single oxidation of an aldehyde, and the second situation results from the reaction of a acid and an alcohol. So here's an example of a reaction of an acid and a base, and it forms the ion, the propionate ion, plus sodium and water. Okay, so you have sodium propionate here. So this is the reaction of, when I said an acid and a base to form the salt or ester and water. In this case, this is a metallic ion as opposed to being as opposed to being an alcohol, but the reaction is the same to form this, what would be an ester if this were an alcohol instead of a base. So carboxylic acids tend to be weak bases. They usually are only about 1% ionized. You remember that acetic acid, for example, has a Ka of about 1.8 times 10 to the minus 5. As I said, carboxylic acids are prepared by oxidizing alcohols to aldehydes and then aldehydes to carboxylic acid. And this is the chain of reactions that occur to form carboxylic acid. Esters, on the other hand, are formed by reacting an alcohol with an acid. So here you have acetic acid, here's the acetic acid, here's the alcohol, ethanol, and here's H2, H2O. You remove that water and you form, here's the functional group for the ester, and you have, in this case, it's acetate, 1, 2 carbons here is the acetate, and this is the ethyl part over here. So here, that's the water being taken off, and once it's taken off, then the bond forms right here. Here's the water over here, and you have this functional group in the middle of the chain. These is you look at where the single bond oxygen is, and you draw a line right here. Okay, not the double bond, but the single bond. You draw a line between the single bond and the carbon on this side, and then you count the carbons here, and that's the last name of the acetate of the compound. And then what's on this side is the first name. Now the other way to do it is to figure out which was the acid and which was the alcohol when they reacted. Because the acid forms the name, the second name, and the alcohol forms the first name. And that's the other way you can figure out how to name this thing. Now, amines and amides are shown right here. An amine is a molecule that has a nitrogen in the molecule somewhere. So you have a nitrogen either on the end, and this is methylamine. You have a single methyl group on the nitrogen. You have two here. This is dimethylamine and trimethylamine. And nitrogen will have a lone pair of extra electrons along with 3 bonded pairs of electrons. So here's your lone pair of electrons. The naming is basically very simple. You just put amine on the end of the name. Now this is an amine that is formed with something that looks like benzene, and so you have the same sort of resonance that occurs, and it has a special name called pyridine. Pyridine is something that's seen in biochemistry, and it is a amine that's formed from benzene. Pyrimine is a heterocyclic amine, which means it forms it has 2 different atoms in the ring. That's what heterocyclic means. Heterocyclic means that there's more than one different atom in the ring itself. And this is the carbon, nitrogen in the ring, thus the name heterocyclic amine. Like ammonia, which is a weak base due to this lone pair of electrons that are available, most amines are also weak bases. And you can see here that methylamine, having that lone pair, has the same sort of structure once exposed to hydrogen ions that ammonia does. Amides have the combination of a nitrogen and an oxygen in the structure. So you can have an R group. Up here is the general structure of an amide. So you can have an R group on any of the available bonds that are left once the carbon and the nitrogen are bonded, and once the double bond oxygen is bonded. So you have one bond left on the carbon and two bonds left on the nitrogen. Now those can be either hydrogens or they can be any functional group such as methyl or ethyl, etc. So here, for example, you have, here's the oxygen and here's the nitrogen. So you have two bonds left over here and both of those are bonded to hydrogen. You have one bond left over here and it's bonded to carbon. This one's called acetamine. It has two, it also can be called ethylamine. This is 1, 2, 3, 4, 5, 6 carbons bonded like this. So you have hexanamine. Hex being because it's a 6-carbon chain, and amine because it has amide, because it has a C double bond O NH2 on the end. So it has a carbonyl group and a nitrogen. And the name attached to the end of this would be amide. Amides are produced by reacting carboxylic acids with amines. So instead of carboxylic acid and an alcohol forming an ester, carboxylic acid plus an amine forms an amide. And it's shown in this reaction here. And you can see in both cases what happens is the water is stripped off and then the bond occurs. This condensation reaction forms a dipeptide from two amino acids and leads to the formation of water. Condensation is when you take out a water and then a bond occurs where the water would have been. So you're taking out a water here. So that's the condensation part. Then a bond forms to replace where the water was taken out. And that's this bond right here. And this, in this case, is a peptide bond. An amino acid has both an amine group, also called the amino group, on one end, and the carboxylic acid on the other end, or carboxyl group on the other end. And so they can bond to each other and form complex amides. And these complex amides are also called peptides. And this, in this case, is a dipeptide because it has two peptides. So, just as a review, before we go through a series of examples so that you guys can practice, here are the various structures and names of the various different types of compounds. This table comes from your book, so you can use this table from your book to study. You can also use this table to make flashcards so that you can use flashcards today, and I strongly recommend the use of flashcards. At the top you can see the alkene is a double bond, so if you have two carbons it's eth, and then it's ene for that name. If it's a triple bond it's ethine, or it's an alkyne. If it's two carbons with an OH, then it's ethanol. If you have two carbons on either side of an oxygen, it's diethyl ether, or ethoxyethane. Remember, an aldehyde has a carbonyl group on the end, so it's ethanal, aldehyde, ethanal. A ketone has a carbonyl group in the middle. In this case, we have two methyl groups, methyl. This is not the usual name we use. This name is different. I'm not sure why they put that in there, but it has 4 carbons, so it would be butanone. Carboxylic acid has the double oxidation, so it has both the aldehyde plus the OH on the end, so it's either ethanoic acid or acetic acid in this case. An ester is a combination of a carboxylic acid and an alcohol, and if you combine ethanoic acid with ethanol, you end up with ethyl from the ethanol, acetate from the carboxylic acid, ethanoic acid. And you can also call that ethanoate if you want to. An amine has a single nitrogen, and if you have a single 2-carbon on with the other 2 bonds being occupied by hydrogen, then it's called ethylamine. If you have 2 ethyl groups, it would be diethylamine or even triethylamine. And then lastly, an amide combines a carbonyl group with a nitrogen, and so you have ethylamide or acetamide. Now, one thing about this table that's a little bit worrisome to me is sometimes they talk about ethyl and use the standard IUPAC name, and then sometimes they take the more common name like acetic acid or acetamide. And so I will accept those kinds of answers, but I suggest that you try to stay constant by using the IUPAC